Alright guys, welcome to this exciting episode of our YouTube lessons. Okay, now I'm Diana Logos here. Now what we'll do is to break down questions, break down theories concerning chemistry, biochemistry, public health, and so on and so forth. So I would like you to like this video, subscribe to this channel, because this video is definitely going to help you out. It's going to show you a lot. Now, I'm going to be pertaining to by today's video to those of us writing the post-utme examination coming up soon. Now, I have a question which says two post-utme questions which can help you. I will try to elaborate and do more, drop more highlights on this. So not just the question will help you, the explanation I make here is going to help you. So please just pay attention carefully. Now, they said flint glass is made by incorporating dash metal. Okay. Now, which metal do you incorporate into glass to get flint glass? Now, flint glass is actually a brighter glass that has a higher refractive index than the normal ordinary glass. Okay, it used to make prism, triangular prism. Those prisms, those prismatic materials are flint glasses. They are flint glasses. Now, first, ordinary glass is made by actually incorporating calcium carbonate, limestone, and what's it called now, and washing soda. So it is, the ordinary glass is called lime soda glass. So if you incorporate limestone and washing soda into silicon oxide and heat to an appropriate temperature, the molten material you get is then cooled and solidified to get glass. As you get, so certain other metals can be added to this glass to get different desire. Now, if you incorporate lead into glass, okay, you are going to get a flint glass. So flint glass is made from lead. You get, so heating lead carbonate or heating lead oxide with silicon oxide in a furnace will give you flint glass. Now, there are other things you can add to glass. Now, it's what we call heat resistant glass. Now, heat resistant glass is actually gotten by heating silicon oxide and boron oxide, silicon oxide and boron 3 oxide with a small amount of aluminium oxide. So when you heat silicon oxide, okay, with boron 3 oxide and small amount of aluminium oxide, you are going to get what we call a heat resistant glass. You have a glass that can easily be softened. Can withstand a high temperature. Heat resistant glass. An example of heat resistant glass is what we call Pyrex. The Pyrex glass used in the laboratory is an example of heat resistant glass. So which metal is basically incorporated to get resistant glass? Okay, it's aluminium, trace of aluminium oxide and boron 3 oxide. I think silicon oxide used to make heat resistant glass, yes, about 8%, 12%, and the aluminium oxide has some trace elements, take the remaining percent. So that's how you get resistant glass. Transition metal is incorporated into glass to get colored glass. Transition metals can be used to get colored glass. If they ask you, the ordinary glass is what we call the lime soda glass. Okay, the ordinary glass is what we call the lime soda glass, gotten from limestone, washing soda, and silicon oxide, obviously. So glass, if you are following, if you are trying to get what I'm trying to say now, glass is a complex mixture of metallic triazosilicate. It's a complex mixture of metallic triazosilicate. So there must be silicon oxide in the process of making glass. And silicon oxide is more very abundant. It's sand. Yes, one form of silicon oxide is our everyday sand we see. Now, next, we said ethanoic acid can be distinguished from ethanol by, how do you distinguish ethanoic acid from ethanol? Now, quickly, we don't use sodium hydroxide. Do you get? Because ethanol will not react to sodium hydroxide. Though ethanoic acid will react to sodium hydroxide. Do you get? But sodium hydroxide is not preferably used to distinguish ethanoic acid from ethanol, because sodium hydroxide can also play a role and react with ethanol, and a trace of hydrogen gas can be released. Okay. So you have ethanol plus NaOH. Though it is rare for a reaction to occur. Okay, reaction can occur. But just that the alkanols behave like this in solution. Alkanols in solution, they tend to liberate hydrogen ion. Alkanols, that's how they behave in solution. And this hydrogen ion can now take up this OH here and produce water. Then the Na takes up, replace the hydrogen ion. Do you get? So what can happen is that a reaction can occur, but reaction will be under certain conditions. Okay? Now, but the best way to distinguish alkanoic acid from alkanols is not using sodium metal. Do you get? Okay, by now you know that both of them can undergo ionization reaction. Do you get? So both of them can react to sodium metal to liberate hydrogen gas. Okay, both of them can liberate hydrogen gas to sodium metal. The best way to distinguish ethanoic acid from ethanol is using sodium bicarbonate. Why? All acids, including alkanoic acid, react with triazocarbonate salts. They react with triazocarbonate salt to liberate salt, water, and CO2. So CO2 gas is going to come out on a 5%. But alkanols cannot react with sodium bicarbonate. So alkanoic acid reacts with sodium bicarbonate or sodium hydrogen triazocarbonate to laboratory. So that's one way to distinguish between alkanols and carbonate. We cannot use metallic metal because alkanols, I told you, produce hydrogen solution. Alkanols can react with metals to liberate hydrogen gas. So at this junction, we'll call it a day. I know this video was helpful to you. Follow for more, watch my other videos. If you're a post-utme student, if you are any level you are, just check the playlist of this channel and you will get this quality updated videos. I recommend the because it's a guide for now.